Hello, today we're going to start looking at graphing exponential functions. So exponential functions look like the equations you see here. Instead of an h of n, you could have an f of x or something like y. But the key thing of what makes it an exponential function is that the variable, in this case n, is up in the exponent. That's a little different than equations we've seen so far for the rest of this year. So we will eventually graph these, but first what we want to do is make sure we know how to evaluate these types of functions. This is the same as when we've evaluated other functions before. Here they've given us the equation for a function. For number one, they want us to find h of 1, which just means we are going to put 1 in for the variable. So since our variable is n here, all of the n's are going to turn into 1s. So h of 1 is going to be 5 to the 1, and then we simplify this. 5 to the 1 power is just 5, so our answer there is 5. Remember, anything to the 1 power is itself. 2 to the 1 is 2. 1,000 to the 1 is 1,000, etc., etc. Let's do the same idea for the rest of these. So next up, they want us to find g of 0, which means 0 is going to go in for both t's. Remember, the g of 0 is just kind of like a label telling you what's going on here. And then when we do the 0 power, anything to the 0 power other than 0 is 1. So 4 to the 0 is 1. 3 and 4, same idea. This time we're plugging in 2 for number 3. I'm going to sub in 2 for both of my a's. To simplify this, I do 4 to the second power, or 4 squared, which is just 16. Last one. This time I'm plugging in a negative 2. It's okay to have a negative exponent. Remember, thinking back to our exponent rules, that a negative exponent is the same as 1 over the positive version of the exponent. So as an in-between step here, I'm thinking 4 to the negative 2 is the same as 1 over 4. Oops, that looks like a 9. It should be a 4. It's the same as 1 over 4 to the second, or 4 squared. We know that 4 squared is 16, so 4 to the negative 2 is going to be 1 over 16. If you'd rather, you can write those as a decimal too. Not a problem there. If you did that in a calculator, your calculator would give you 0.0625. For graphing, sometimes it's easier to think of things in decimal form, so you're welcome to do it that way too. Either one is fine. Now let's move on to how we graph these things. Since this is an online class, where I'm not going to have you graph by hand because it's pretty cumbersome to draw your own graphs, especially with these, since you can see our range, our y values cover a lot more ground than we're used to. So instead, I'm going to have you choose the correct graph. These directions here say something about domain and range and horizontal and asymptote. We are not going to worry about that. We're just going to choose the correct graph. So I'm going to have you follow the same process every time for all of these. Every time we have an exponential function, we're going to make a table of values. I'm going to have you use the same 5 x values every single time, because if you use those 5 x values, it's enough to help you find your correct graph. We're going to do x values -2, -1, 0, 1, and 2. And then to find our y values, you are just plugging into your parent function here. So for number 5, what we're looking at is 1/3 to the x. So going down my table here, when I plug in -2, I'm thinking 1/3 to the -2 power, which is +9. If you're using, I'm going to show you Desmos here for a second. If you would like to use Desmos for this, if you want to do 1/3 to the -2, so type in the fraction 1/3, put it in parentheses. And then to do an exponent in Desmos, if you hit this A to the B button, you can type in any exponent you want. So I'm using -2, and Desmos tells me it's 9. You are welcome to use Desmos for any of your calculations. So to do any exponent that's not 2, it's A to the B. I'm going to get rid of our Desmos though. Okay, and so now let's go down the list and do the rest of these. For -1, I'm thinking 1/3 to the -1, which is +3. For 0, I'm thinking 1/3 to the 0. Anything to the 0 power is 1. 1/3 to the 1 is just 1/3, or if you like decimals, 0.33, repeating. And then 1/3 squared is 1 over 9. Remember, when we're using an exponent on a fraction, we square the top, we square the bottom. Or that's the same as 0.1 repeating if you'd rather. So now what I'm looking for is the graph that goes through all of these points. -2, 9, -1, 3, 0, 1, 1, 1/3, and 2, 1/9. So letter A is not going to work because the point -2, 9 would be right here. And our graph definitely does not go through that, so it's not A. Letter B does not go through -2, 9 either. And so that leaves us with letter C and letter D. Letter C, -2, 9, that works. Let's see if our other points are on there. Next point is -1, 3. Looking good so far. 0, 1. And then the fractions we know are going to be between 0 and 1, so C is the correct option here. Let's see why D doesn't work. -2, 9, you can already see our graph doesn't go through that, and so the other points don't work out either. So, process here is to make your table of values and then find the graph that goes through all of those 5 points. For the fractions, this might be a little hard to see. Just do the best you can. Also notice, I didn't point this out to you before, that every box here is 2 units. So for instance, 9 is halfway between 8 and 10. 1 is halfway between 0 and 2. Watch out for that. We just use every box being 2 units in order to make the graphs not be quite so gigantic. Let's try another one. So I'm going to make my table of values again. We're always going to use the same 5 points for these every single time. Same 5x values. Give myself a little more room to write this time. -2, -1, 0, 1, and 2. Every time. This time we are plugging into y equals 3 to the x. Going down my table, 3 to the -2 is going to be 1/3 squared, so 1/9. 3 to the -1 is going to be 1/3 to the 1, or 1/3. 3 to the 0 is 1. 3 to the 1 is 3. 3 squared is 9. Something else you might have noticed is that when you plug in 2 and when you plug in -2, those values are reciprocals, 9 and 1/9. When you plug in -1 and +1, those values are reciprocals as well. So you can fill in your table in whatever you want. If you want to do the positive exponents first, then your negatives and just your reciprocals, you can do that. I'll show you that in the next problem. Or if you want to just type everything in Desmos, that works too. So let's go ahead and graph these. -2, I'm actually going to start with I'm going to go backwards. I'm going to go with the points that aren't fractions because those are going to be easier to see on the graph. So I'm going to start with the point 2, 9. I want my graph to go through the point 2, 9 if it's the correct graph. So 2, 9. Letter A looks like it might work. Let's check the other points. 1, 3, 0, 1. And then the fractional values are also in the right spot too. So A is the right graph for this one. Let's just check out why the other graphs don't work. B does not go through the point 2, 9. C does not go through the point 2, 9. And D does not go through the point 2, 9. And that is it for today's lesson. So when you get the graphing part, make your table of values and then find the graph that goes through all of those table of values, all those points in your table of values. You are welcome to use Desmos to help you do the evaluating. You are welcome to fill in the table in whatever order makes sense for you. Whatever works for your brain and helps you get the right answers, what I want you to do. That is it for today. Have a fantastic day.